All right, good morning, everyone. Thank you for getting up early this morning and making your way into the first talk today, which is the Science Engagement Roundtable. As many of you know, science and research is one of the core reasons why we exist. We're here to serve the researchers, provide them the services and capabilities that they need, and an important way in which we get that information is engaging with the scientists and the researchers. So what we're going to have today is a panel that is going to talk about how the different NRENs and their staff are working with the science teams, how they get engaged with the local cyber infrastructure engineers and partner networks. Oh, sorry. And talk a bit about their approaches, and hopefully we can learn from one another. And at the end of the session, we'll open it up to discussion and hopefully get some good questions from you in the audience about how, what we're learning about how we can be successful engaging with the community. So the first speaker today is going to be Eli Dart from ESNet. Then we've got a slight change to the schedule. We're going to have Jakob Tendel, DFN, then Roberto Sabatino from Géant, and then last will be Sylvia Kuipers from SurfNet. So without further ado, I will turn it over to Eli.
Thanks, Steve. Excellent. Morning. My name is Eli Dart. I'm a network engineer for ESNet. I work in the science engagement group. Our job is to work with the different science collaborations, and as the way I like to describe it is map them onto the infrastructure. So I'm going to talk a little bit about ESNet and what we do, and then I'm going to go into how we think of and structure science engagement, and see how that all works out. So what is ESNet? ESNet is a mission network funded by the Office of Science of the U.S. Department of Energy. So we don't do this just to do it, even though it's fun to do it. We see networking as a means to an end, which is scientific productivity. That can mean doing science at all. It can mean doing science better than you otherwise might. Or it can mean advancing both the state of networking and the state of science to come to a common, better place. So our primary goal is to create a world in which scientific discovery is not constrained by the physical geography of the scientists, the instruments that they use, the computing facilities they use, sources of data, and so on. Hey, it actually works. So here's the obligatory network map, right? So everybody loves to display network maps because we're all networking people. And you might think, well, that looks like a map of your typical internet service provider. In fact, that is not the map of an internet service provider. It's the map of a DOE user facility designed to overcome the constraints of geography. Right, so a DOE user facility is a specific, in our world, facility is a reserved word. That means it's a specifically funded item of major scientific research infrastructure, right? So whether it's a genome sequencing laboratory or a particle accelerator or a fusion reactor or a high performance network, it's designed specifically for a purpose in the science complex, and we run it in that way. So how do we remove the constraints of geography? We provide the capabilities necessary, and we work very, very hard to optimize it for the kinds of things that you need to do data-intensive science. So data acquisition, data distribution, data placement, and so forth. So the other thing that's interesting is that many of our constituents don't actually talk to each other all that much. I mean, yes, they do, right? Of course they talk to each other. But if you actually go and do the traffic analysis, on the order of 80% of the traffic that traverses our network has one end of the connection outside of the DOE science complex. So whether it's data originating outside and coming into the laboratories for analysis, or data originating at the laboratories and then leaving the National Laboratory Complex for analysis, the vast majority of the traffic involves not just ESNet and our direct constituents, but our collaborators and our constituents' collaborators, right? And so what does that mean? It means that our success is dependent on the success of others. Right, so a nice way to put that is that we're necessary but not sufficient, because as we all know, we're all in the networking business, right? Networks have a shared fate, and our users depend on us. They also depend on our partner networks and on the site networks of the remote collaborating institutions. The Department of Energy invests on the order of $1 billion a year in research at external entities outside the national laboratories, universities, and so forth. So everybody matters in this, and as we all know, right, science is end-to-end, right? This is, you know, you can go look at the data and you get the hard fact that yes, it is end-to-end. What does that mean? That means we all have to work together. So working for a mission shop means we're focused more on outcomes. It's about getting the mission done. So those outcomes increase scientific productivity, sure. DOE is pretty famous for big team science efforts. So something that isn't possible with a single principal investigator, you know, working alone in their own lab. Although we do have that type of science too. But the hallmark of the DOE National Laboratories is big team science, big projects, getting big stuff done. And so what you get from that then is new transformative things where something is now possible or has come about that would not have been possible without that large-scale team effort. So we don't control everything that contributes to the outcomes that we're interested in. I mean, so we have an interest in outcomes. We know we don't control all the pieces, and we can't. Why? We don't own all the pieces. We don't have root on your stuff. You don't want us to have root on your stuff, right? That's cool. And so we have to work, we have to collaborate with all of our partners and all of our constituents, as well as, in some cases, their partners and their constituents. So once you start looking at outcomes rather than just focusing on technologies, it can change your thinking a little bit. So there's sort of this old legacy model for operating networks, right, where you say, okay, I've built this beautiful thing, it's wonderful, it functions perfectly, and you get to tell me if it breaks, and then if you saw that it broke, I will sort of deign to look at it and see if I can fix it. Okay, that operational model is obsolete. If you care about outcomes, you have to be proactive, and you have to make sure that not only are we doing the right things, but we are helping our constituents do the right things. And if our constituents can't use the infrastructure, either we need to help them change what they're doing, we need to change what we're doing, or both. So there's the vision, right? Discovery unconstrained by geography. So how do you bring that about? There's a set of goals here. This is from sort of visionary mission slideware stuff. But there's a couple of things we have to do. We need to understand how to understand the needs of our constituents. So we need a methodology for doing that, right? How do you actually go and figure out what your users need? Once you've got that figured out, you need a mechanism for taking what you've learned and putting it to use, whether that's sharing best practice with the community, working with individual constituents or projects to improve their results or their outcomes or their operations. There's a variety of things to do. So getting through that then is what we call science engagement. So there's a nice mission statement there. Our job is to ensure that all the science collaborations that we serve, every scale, every domain, have what they need in order to get the maximum benefit out of the infrastructure that we build for them. So we're quite a multidisciplinary team. We do several things kind of all at once. And I'm going to go through each of these in a little bit of detail here. We have to understand what contributes to the outcomes that we're interested in. We have to understand how networks contribute to that, which gets into an architectural discussion fairly quickly. There's a systems engineering component to this because, as we all know, this stuff is complicated enough that you can't simply take one part of it and say, okay, I'm going to optimize this, and then everything will be just fine, right? It doesn't work that way. This is all integrated system stuff, so you have to take a systems engineering approach to getting all this done. Collaboration, of course. We can't do this without collaborating. And then finally, you have to be able to get the information out there in some kind of useful way, and so we do that with workshops and webinars and some other things. The clicker only partially clicks. So, how do we understand what's actually important? We have a requirements process that we use. It's a formal requirements process through our program at the Department of Energy. The Department of Energy has 6 program offices. We work with each of them in turn. And we bring in they bring in their scientists, the ones that generate the most sort of data and have the most need from the network infrastructure. We go through, we talk to them, understand what their needs are, characterize not only their current but their future networking needs. Now, there's a key thing that you have to remember to do that. If you just ask a scientist who's not a networking expert, they're a chemistry expert, biology expert, physicist, whatever. You say, what do you need from the network? 9 times out of 10, they're going to come back with, I want 10 gig to my laptop. Okay, well, that's cool. I'd like 10 gig to my laptop, too. But from a network design and network engineering perspective, that's not actionable. And so rather than ask somebody what they need or what networking do you need, right? And all you're going to get is what they think they should tell a network person based on their understanding of networking. What you do instead is say, what are you trying to do, and how are you trying to do it, and what do you need pragmatically in order to do that? Then we take that back in and map that onto a network infrastructure and make sure that we then build the services that they need to get their science done. There's a nice side effect of that, which is that if you work with your users in this way, the things that you learn from them, right, and that informs what we do, and it gives us several things. We can see patterns of problems. These people are having problem X. Well, these people are having problem X too. They'll never talk to each other, right? There's chemists over here and cosmologists over here. Okay, fine. But if we start to see patterns of common problems, that gives us a point of leverage that we can use to better build the network infrastructure that we've got. And so you can get significant sort of solution scalability by approaching it in that way. And from that, you also then come up with best practices. So our success is necessary but not sufficient, so we can build the network beautifully. We need others to build their networks right as well. Anyone who's done performance engineering knows that. So we do a variety of things to help each other improve and build our networks well. Our contribution to that discussion is the Science DMZ model. So this is an architectural model for achieving high performance in the general case for cyber infrastructure used for data-intensive science. So there are several key components to the Science DMZ model. We went over this in the session on Monday. So there's the enclave itself, perf sonar for test and measurement, dedicated systems for data transfer, we call them data transfer nodes or DTNs, and then appropriate security designed to defend that infrastructure while maintaining its performance. There's a knowledge base that captures all these ideas and a whole bunch of other performance tuning ideas as well. But working with the community on architectural best practices is a key part of what the Science Engagement Group does. In addition to that, we just help people solve problems. That turns out to be really, really important. The scientists need somebody that they can call that will help them through their stuff. So when we need to, we hand it off to the network engineering group. We also collaborate with the research side of the house in ESNet, so whether that's on the design of data transfer nodes or advanced SDN architectures, particular performance engineering for particular systems, tooling, whatever it needs to be. And I'll reiterate, we found it to be incredibly important to help to be involved in helping other people out. So you can think of troubleshooting work as extra work, right? Oh, I thought I was going to do X today, but then somebody's stuff over here broke, okay, and so now I'm over here fixing the stuff that broke, right? So you actually learn from that. That's enabling technology, right? You learn a lot from helping people through whatever their problem happens to be. Keeps you sharp. You get new skills and new experience that you wouldn't have before, and it gives you intelligence about the kinds of problems that the science community sees, and therefore what common solutions can be undertaken to help fix those problems at scale. So I've said collaboration a couple of times, and there's a reason for that. It's important. We work with not only just amongst ourselves and within our organization, but with the other DOE facilities. So these are computing centers, particle accelerators, and so on. We have an effort ongoing now, which we call the super facility model, where you take two scientific facilities, the canonical example being a free electron laser, an X-ray synchrotron, or something like that, and a high-performance computing facility that has the ability to do the analysis of 100 terabytes a day or whatever it is that first facility generates. You bolt them together by means of a high-performance network, and you get this aggregate facility that has capabilities that the facility that any one component could not have. And so it's a wholes greater than the sum of the parts thing, but it requires a high-performance, feature-rich network to knit it all together. We have some pilot efforts to improve science outcomes, science DMZ and perf sonar and so on. And then we have some larger scale collaborations such as the EYR Global Program and ongoing development efforts in perf sonar. We also do a bunch of work just talking to people in sort of a workshop and webinar context. Something that's been very useful to us has been what we call the Operating Innovative Networks workshop series. So this is a partnership between ESNet, Internet2, and Indiana University. And a key component of this is we don't hold them at a central location. If you hold it at a central location, then the only people who show up are the people who can get travel funds. Right? And so what we do instead is we go to somebody else's location. It's usually sited at a university. And so we get to then talk to the people who are actually on the ground, actually doing the work, solving the problems every day. They're not going to get travel budget, right? Budgets are tight. They're just not going to be able to travel. But so it allows us to interact with them and make sure that they have the tools and the understanding that they need to be effective. And it's been really, really useful to do that. And then we do webinars sort of as needed. My colleague Jason is the webinar king. He just pounds them out. He's amazing. So if we're going to tie all this stuff together, right, so there are a lot of these sort of different components that you can look at, right? This is all part of a larger vision, right, which is a focus on outcomes to enable data-intensive science. Right? And really, we mean it when we say we're trying to make sure discovery is unconstrained by geography, right? That's for real. And that's why all these different things, if you knit all these different things together, you end up with a powerful way of achieving that mission. So, we don't know everything, though. And you learn new stuff every day. So, right now, we're doing what we have found in our experience to be effective, but we know there's more to learn. We're very interested in collaborating with others in the community that are doing science engagement. We're very interested in learning what your experiences are and what you have to teach us. Thank you very much. I'm going to hand it off to, yes, okay, Roberto's next. Thanks.
So just, what do I have to do here? Good morning. So my name is Roberto Sabatino. I've been working for Jean for several years now. I think many of you know me. So that's a good starting point, I think. So I'm going to give an overview of how the Jean project is structured to interact with international collaborations and users on an international basis to tackle some of the problems that Eli has outlined as well. I'm going to start from the services that are offered across the Géant footprint and backbone, and relate that to what NRENs and campuses do to deliver services end-to-end to users. So here's a snapshot of some of the services that Géant offers. We've got connectivity services from circuits from up to 100 gigabit, from circuits between 1 and 10 and 100 gigabits, IP access, VPNs, performance monitoring. Then we have edge-again services, cloud services. We also have test beds and Ederome. There's a whole set of services that are available to the users of the Géant backbone, which are the NRENs, of course. Now, if we take this a step further and look at the end users, we all realize that to deliver services to end users, there's a whole chain of delivery. So we have Géant that delivers services to NRENs, NRENs that deliver services to campuses, and campuses that deliver services to scientists, researchers on site. There may be some more complex arrangements as well, regional networks perhaps. We have also, if we have the case where a user is in the US, for example, and another user is in Europe, we have yet another chain to go through, say, for example, through YesNet and the chain down to their users as well. But what's interesting here is that we're talking about service catalogs offered by each domain, and these service catalogs in general differ. So the service catalog that a researcher at a campus receives from its campus is probably different from the service catalog that the campus receives from its NREN, and that service is probably different from what the NREN receives from Géant. And what's more, if we take two campuses in two different countries, or even within the same country, those two service catalogs may differ. Certainly, if we pick two NRENs, NREN A and NREN B, the service catalogs that they offer to their users are certainly different. The conditions of use are different. The funding schemes are different. So you can see that the whole chain, if you look at the international service delivery chain, there are all these different domains with different catalogs and different conditions of use. So what does this mean for the user? Or the users? So imagine two collaborators in two different countries. What can they actually achieve end-to-end, and under what conditions? How can they get access to those services? How can they use them? And how do they share eventual costs that emerge? Because in one country there'll be one business model in one campus, and on the other side there'll be a completely different business model. So how do they get around this? That's only 2 users. Now consider 10 users in 10 different countries with 10 different combinations of, well, more than 10 really, of services available in various domains with the different business models. How does this work for a collaboration that involves multiple users in multiple countries? This is where the Géant user liaison function aims to add value and resolve for the user this problem of identifying the services that are available to them and identifying how they can be used, how they can be accessed, and under which conditions. We have this liaison function. I'm the team leader of that function within Géant, and we work with the user, with the stakeholders of the various domains to formulate a solution which is technical, which is organizational, and which is also financial, providing the information necessary for the users so that they can actually do their work ultimately. We also like to call ourselves the voice of the customer within the Géant organization. So when we go out speaking with users, we hear what their needs are, what their concerns are, and we bring that information back into the organization, and we try to influence the service developments so that the roadmaps of these services can actually meet the needs of these international users. We don't do this on our own. We do this in collaboration with the NRENs, of course, and in particular we identify what we call the lead NREN, and the lead NREN is that NREN which we believe has the most stake, the highest interest in serving that user. Maybe because they host an instrument, for example, maybe because they host the organization which is the coordinator of the project. Various reasons may lead to identifying which is the lead NREN, and we work very tightly with that lead NREN. So how do we do it? And here we pick up on what Eli said earlier. We don't ask what does the user need. We try to work with them to find out how they're working, what they're doing, and from there translate that into networking requirements, and from there formulate services that meet their actual needs. We map it to the network, we map it to the services that we have. And to help us do this, we bring in the experts as and when needed. We cannot expect any one of the user relation function team to have all the expertise and all the servers and technologies that might be needed. So we bring in the experts from our community, for example, the AAI experts or the VPN experts, as and when needed to have these discussions with the users and with the NRENs involved and all the stakeholders involved, really. And from there, we actually formulate lots of information to document what is required to support the needs of this collaboration. And from there, we proceed to implementation. There are a number of success stories where we have applied this working principle. Here's a list of them. I won't go through the details, but this is just a few of them. UMETSAT, for example, which you have heard here during the conference. There's work going on with Copernicus. There's work going on with ADA, which is the European Integrated Data Archive for Seismology, which is a key stakeholder of the EPOS ESFRI. Confine, which is a future internet project. So there's a lot of work going on, and these are just a few. There's many more in the pipeline happening. That's all I had to say for now. So I can hand over to our next contributor. Thank you.
Okay, here we go. Good morning, everybody. Thanks for coming. I'd like to present the perspective of DFN, Deutsches Forschungsnetz. We're the German National Research Education Network. Let me first give you a quick overview of what I'm going to be talking about. I'd like to present the DFN network, then say a few words about the DFN organization and how that impacts our paths of communicating with our constituencies. Talking about activities for subscriber relations and partner relations, direct science outreach, and some of the lessons learned and the way we're going to be moving forward. Just a quick overview of our network. Germany, the red circles are our core network nodes from where access links cover almost all of Germany and reaching our users. This is an overview of our network at a slightly more symbolic level. We have a super core at the heart of our network, which will be upgraded to 2x100G next year, with lobes heading out north, west, south, and east at 100G speeds into the periphery of the network, from there connecting out to our core network nodes. So we are working and investing in our network to best serve our users. DFN is not only connected to scientific organizations and research, but we also have commercial connections outside of the network to some commercial providers, commodity internet interconnections to best serve our users' interests in that area. But one of the most important connections, of course, is to the GEON network, where we have 2x100 gig interconnects, one in Frankfurt and one in Berlin, to service the needs of our user community to reach the worldwide research and education networks, and in reverse, the international community to be able to reach Germany's excellent research institutions. The traffic on our network has seen moderate growth over the last years. This is over the last 2 years. However, we expect traffic growth to sharply increase in the future, caused by some new, very bandwidth and data-intensive projects coming online. However, one of the complications there is that the timeline, the precise timing of these developments are currently slightly uncertain, so we are preparing ourselves to be flexible in that respect. Peak data rates are also increasing throughout our network as a direct result of investments in local infrastructure at sites being able to push or pull those increased data rates from and into our network. The number of subscribers to our services have also increased over the recent years. From 2007 to 2015, you can see here there's a steady increase in services that we are providing. Let me just point out that DFN is a membership organization that is governed by the members. Many of our subscribers are members, but that is not a requirement. Typical DFN subscribers are high-end, high-performance computing sites, such as the very well-known Gauss centers for supercomputing, but also leading research and data processing centers, many of whom belong to research societies like the Helmholtz, Max Planck, Fraunhofer institutes. In terms of numbers, one of the largest of our constituencies is academic research, universities and other education and research organizations. Germany has over 640,000 academic staff, of which over 350,000 are researchers, and that's just in academia alone. So we have a very broad base of users that we are serving, and a very high peak of very interesting leading-edge big data research that we are also serving. So we have a very wide area. One of the core values in our relationship to our subscribers is trust. We invest a great deal of effort into knowing our subscribers, into interacting with them, and to build trust and understanding of our respective needs, requirements, and interests moving forward. We hold biannual membership meetings where the constituents discuss and also authorize future activities of DFN. We have biannual workshops with our subscriber IT personnel where we discuss developments in the technology, best practices, and building that trust that is important. And we also have several other specialist committees. We also have the concept of trusted subscriber representatives. Those are named individuals at certain subscriber sites that are authorized to request changes to the network settings, for example, in such cases as DDoS attacks. And we will trust them to a great extent to know what is best for their institution. We're also investing a lot of effort into certificating our services to further build the trust in the services that we provide. So all in all, we have a strong bottom-up feedback from our user community, from our subscribers, but also we have a strong sense of accountability to those subscribers. We don't have a high government department or funding authority telling us what to do, giving us requirements. DFN is fully funded by subscription fees, and we are 100% accountable to our subscribers, and only to our subscribers. The partner community is also very important to us. Partners in the research networking community include European and overseas NRENs, but also transnational organizations like GEONT, and even international twinning partners such as KenNet in Kenya and Africa. We're involved in many collaboration activities that are aimed at improving the ability of our network and our partnerships to drive science. We've long been involved in the GN series of projects, now GN4, phase 1, and these are bringing people from all partner organizations together to communicate and to develop the services that we're able to offer. One focus of these activities is cross-domain networking performance, which is increasingly important for international distributed science activities. Among those is the perf sonar development, EduPERT, performance teams, or such things as multi-domain VPN, which is a great tool for distributed science activities. Other services that we offer there, which greatly ease the working or collaboration opportunities for international science groups, things like federated identity also. At the same time also, DFN is involved in direct outreach to scientists. We've just heard the reasons for doing this, so I won't go into that in too much great detail. Specifically for Germany, DFN has just awarded the newest X-Winner award. Maybe I should just explain the pun here. Our network is called X-Win. So the X-Winner award for young researchers rewards excellence of use in networking for science. DFN is also involved in the Enlighten Your Research Global Initiative. Since 2015, DFN has been a full-up partner. We're very happy about this, and we're looking forward to improving the science collaboration activities in the future. The important thing for us there is to identify and to drive new use cases for improving scientific work using our networks. From all these activities, we've drawn some conclusions in the context that distributed science activities are growing fast, and at the same time, science data volumes are growing even faster. We are seeing network usage patterns varying as each individual scientific community develops their own big data workflows. Some differences become apparent. We want to know about these differences. We want to be able to understand them. So from these conclusions, we feel that we need more granular understanding of the varying network requirements. And at the same time, we want to develop a more interactive service model for those network services that can benefit from a little individual customization. And we want to orient ourselves on those requirements. So in future, we want to keep building an outstanding network that serves most science users most of the time perfectly well. But at the same time, we realize that there are some scientific applications and activities that can benefit from a little closer attention and from a bit more communication along the value chain of science networking. At the same time, we want to promote the capabilities of advanced networking to the scientific community to maybe improve their understanding of what we can do for them to improve their science. Also, we're working on network efficiency, fully end-to-end. As we all know, often the bottlenecks of high-performance networking are not in the middle, they're at the very end, in the last mile, on the site. So we are working with site IT, who we know very well in Germany, to step by step understand these bottlenecks and to work to eliminate them. And also, we're interested in helping provide tools to the end users that facilitate the adoption of best practices to get the most out of the great network that we have built. Thank you. And now I'll hand off to Sylvia Kuipers from Surfnet.
I have to do nothing. It all works by itself. Okay, hi everyone. I'm Sylvia Kuipers from Surfnet, Community Manager Research at Surfnet. And as DFN, Geant, and ESNet, we are an NREN. And thank you all for coming, because I know it's very early today. So, Surfnet. So we have the Surfnet network, Surfnet 7. It looks a little bit like this. We have more than 11,000 kilometers of dark fiber to the institutions. They are very well connected, and they have Ethernet connections, LightPath connections. I think everything is good. Yeah. Cross-border fibers to connect to the outside borders of the Netherlands to other countries. And we have Netherlight and the M6 to connect to the other countries as well. So what does this mean for our researchers in the Netherlands? So I just made 2 graphs to show you how many connected institutions we have in the Netherlands. On the left side, you see the actual numbers of institutions. On the right side, you see the percentages. So we have 14 universities in the Netherlands, and they are all connected to us. And we have 8 university medical centers, and they are all connected to us. And we have University of Applied Sciences, 71, so about 86% of those are connected. And then we have community colleges who only got connected last year, I think it was April or May, and there are already more than half of those that we have connected as well. And then, of course, we also connect to research institutions, libraries, and other higher education. So, that's nice. So all these institutions are well connected, and does that benefit the researchers enough? Well, there's a changing research environment, and also from the funding agencies, these researchers are pushed to collaborate, not only nationally, but also internationally. And this will change our research environment in the Netherlands as it does in the rest of the world as well. So there's a need to collaborate, as Eli and Jacob and Roberto also mentioned. And this needs something extra. And we have been working at SurfNet to make this possible for our Dutch research as well. So collaboration is a key to success. In 2007, we started with Enlighten Research because we had this new product, the LightPaths, and we wanted these LightPaths to be adopted by our researchers in order to improve their research. And that's when we started Enlighten Research. So we have a national edition, and in 2013 we had its 4th allocation. The 5th will be next year. And this year we also have Enlighten Research Global in its 2nd allocation, already with 13 partners included. And we're now going through the proposal process, so we're looking forward to update you on that at a later time period. So, back to the research in the Netherlands. In history, SurfNet was always able to help out the happy few, the researchers that had huge amounts of data, that knew us already because they basically had to. If they didn't know us, then they would not have sufficed in their research. But we want to also help out the researchers that are not so big on science, that are using a little bit less data, but still can benefit a lot from implementing IT in their research workflows. And that's also why we want to push our support not only to the happy few, but also to a little bit to the right, to include more researchers that we can help out. But we need to scale this. So we need a strategy to make this possible with only a few people at SurfNet that can be able or that are able to do this. So we need to have blueprints, good practices to show researchers and IT departments what they can do with our networks, but there's more. And that's why we started the Support for Research program. So SurfNet is an NRAN, we have the network, we have Eduroam, we have authentication, authorization services, SurfConnect. But the researchers look at their data and they want to move their data, they want to store their data, they want to compute on their data. So SurfNet basically is not enough. And fortunately, Surf, our mother organization, also have other organizations operating companies, such as SurfSara, which is responsible for the high-performance computing services and visualization services. So we started to think about, well, okay, so SurfSara also needs to reach out to these researchers, because researchers need to use these national services as well. What about if we collaborate with SurfSara and with the Netherlands eScience Center and with SurfMarket, who we already know, and together we go to the institutions, talk about the whole story of services we can together provide, and that way researchers not only think about their data, how they can move it, how they can store it, but also we can immediately talk to them about their network needs if they need them as well. So that's why we started the collaboration, the Support for Research program, to better facilitate the data-intensive research and further integrate the research or the IT in our national research infrastructure, in our research projects. And we did it even a little bit further. So we not only collaborate with our SURF operating companies, but we also collaborate with Dutch research institutions, the institutions themselves. So we go to the IT departments, to the libraries, and we talk to them and agree upon how we can help out their institution. So there's not just one template to do this. We go to each institution and have a specific template for them. And then we also talk to the funding agencies, the NWO, which is kind of like the National Science Foundation of the Netherlands, the Zonneway, which is the same, but then for health. And by talking also to these funding agencies, we are able to bridge the gap between IT funding and the needs of the researchers. So that's how we are able to better showcase our network and our high-performance computing facilities, and give a bigger package to our researchers, and it works. And at the same time, we also collaborate to train the local ICT or IT support staff with all the 4 SURF operating companies. In that way, we are more efficient about this as well. So our goals with the Support for Research program has 2 goals. Outreach, the best practices, the documentation. We also have a website, which I will show next. We go to on-site events for ICT support staff and researchers. We engage with ICT staff and researchers. We engage with ICT staff, which engage with researchers indirectly. We engage with ICT staff that engage with other ICT staff. And then we have also our research special interest groups, 3 of them, through which we also engage more ICT staff and library staff as well. And then we collaborate with the national science funding agencies, of course. And then the support, again, we have a training program. We collaborate with the local research support teams. And we have coordination between NRENs, National Supercomputing and eScience Centers. Next to the website we set up, we also have one email address. So researchers don't have to look for which email address they need for their data questions or for their networking questions. They can just send an email to this one email address, which makes it easier for them to find us, if they find us. So this is basically what our Support for Research website looks like. We have a services overview, and from that they can click for more information. So what are the questions of the researchers? That's also something that we think about. So here's a slide with some questions that we hear a lot. It's important to think about that when you're writing up best practices and when you're collaborating to learn from these collaborations and then to reach out again to the rest of the community to explain what the benefits were for these other projects. And then we, of course, discussed this with the ICT departments, because in the end, to scale this up, they also need to communicate this to their researchers. And we do something else. So we have all these services. I can show it here. We have a lot of services. We have compute services, data services, visualization services. We have the connectivity, the network. We have collaboration infrastructure. We have the support we can give with SurfShare and SurfNet. And we have SurfMarket, which is able to negotiate better prices for software and stuff like that. So we also explained to our researchers when they are likely to come across these services by taking the data lifecycle and then by plotting these services that we have on the data lifecycle, so that they understand when they probably need to think about something that they will need in their science. So that's the services. Okay, so results to date. We are collaborating with our Surf operating companies. We are getting there. It's tough, but it also gains us a lot. And in the end, it's all for the researchers, so it's good. And also, we get feedback from our institutions, and they really like to work with us. They see the benefit of our approach, and they come to us. We give presentations, and institutions come to us. They say, hey, you should come to our institution as well, because we really want to work with you. So that's good. And also, we have projects, big projects, that come to us because they've heard of our Support for Research program. And there's, for instance, the ALS project, better known for the Ice Bucket Challenge. They received a huge amount of money to genotype a lot of patients. And they needed help because they wanted to get a link from Illumina to SurfShare, where they would store the data, and we helped them with that. And also there's a university building a new facility for 2 universities combining their health and life science education and research, and they are combining it into one building, a new build. And they came to us to ask about how they already, before it was even built yet, could think about how to integrate the network and how to integrate the connections to the high-performance computing facilities. And that's also, I think, a nice gain of our program. And many more projects that come to us already. So to summarize, it's important to offer, for us, it's important to offer an integrated solution, because otherwise these researchers are just overwhelmed by everyone trying to get through to them. And the collaboration is key, which my colleagues here said already. Communication is key as well. We need our researchers. We need to understand our researchers' problems, and we need to understand this before we start with the implementation. We need to get everyone around the table if we implement something, and we need to manage expectations. And also, we need to make clear from the start that we also want something from the researchers. For instance, a best practice. We need them to be ready for an interview or other outreach opportunities. So we will continue with our Support for Research program. We will publish best practices. We will improve our integration with Surf Research Service portfolio on our website. And we will have a workshop on 24 to 25 September about our services. And to this workshop, we invite our local IT departments. And we are still improving our Support for Research training for our IT personnel and also for the researchers directly. So future opportunities. So still, we face problems as well. There's a problem of scalability, continuity, sustainability, cost, etc. You just don't have more people. So how can we be more efficient about this? How can we join forces globally, maybe? Can we join forces globally, maybe? So I put down a couple of questions. Is support for research maybe something that we can do globally? Or is it a must, maybe, because science is becoming more and more international? And if yes, how should we go about this? So that's maybe something that we can discuss later. And would it be an idea to try to get funding for this for these initiatives, so that we can collaborate more? And what do we need to be able to ask from our CEOs to make this happen? Time, money, support, you name it. Can we do this with only the NRENs? Or should we also include national HPC centers, or maybe institutions like, or allocations like EUDOT, PRAISE, EXCEED, you name it. That's also something we should think about, I guess. And then, what about setting up a mailing list for science engagers of our NRENs all over the world? Because I think we can learn a lot from each other. I've heard during this conference a lot of nice initiatives. I think we can still learn from you as well. So I thought this would be a nice idea, but I would really like to hear your views on this. And also, what about I've heard some nice stories about NRENs making MOOCs for their students, for their primary school students already. Is that something that we should do as well? And maybe we can work on that together to make this happen. So thank you for listening. I will give the floor to Steve.
Oh, thank you. At this point, we'd like to open it up to questions from the audience. You've heard a lot of different ways in which people engage with their respective communities. And go ahead, Florence. Yeah, they're coming around with one there.
Thank you. This has been great, and so much has been done already, but I think there's so much more we can do. What I've found this week is that we all say that even though we've been working with researchers and scientists a lot, they're still having challenges finding us, knowing how we can help them, getting onto the network. And I love the recommendations that were just made. So I'd like to understand, do we have some type of support for research, program advisory group yet? How do we create something like that? Could we potentially, Eli, leverage your Science DMZ and create like a Science DMZ interface that is this starter kit that we talked about when I was visiting you at Berkeley, that USC has asked me for and Michigan has asked me for, and I think all of us nod like this when we ask, does anybody need something like this? And I think it would be wonderful if we work together on this. Another thought that we had, and Leif had to leave from Sweden, but was potentially creating a little survey. We could agree on what questions we want to ask, maybe just 2 or 3, to understand what the needs are of the researchers that we're not meeting. Like I tried to use your network, I couldn't figure it out, I gave it 2 weeks, I'm done. Whatever it is, maybe the high energy physicists we've been hanging with a long time, so they know, but the microbiologists and the computational biologists and the genomics and healthcare guys say, I have no clue even where to start. So I think we need to find what the user's needs are. Working together would be great to identify patterns and then fix them together. It's just such a rich community we care so much. I think it would be wonderful if we more formally teamed together and then created like a step function of, we'll do this first. What do we already have? Put it on the table. Science DMZ and support for researchers. What does that mean? How do we expand it? What do we, what do we do as a team and separately? So I know that's a lot of data, and I'm from New York, so I speak quickly. I'm sorry about that. But I'd like your thoughts on if any of this makes sense.
Yeah.
I think the Enlighten Your Research is kind of an effort in that direction. It is. I don't know if you want to talk a little bit more about that.
So I invite everyone here, to go back to your, I invite everyone here to I know, reach out to us. We will get your email addresses. We will make a list. And then we can also explain maybe a little bit more about our NIT research efforts, because that's basically, we started off with 5 countries being involved in that. And we saw for those researchers, it's so hard. So not for the high energy physics scientists, because they've done that for years, right? But for the scientists for which it's new to collaborate internationally, it's so hard for them to make it happen, to get the network optimized, to get the collaborations working, and NIT Research is really a program that tries to create a package with all these countries already that are already collaborating, just to make sure that we are there to help them out with making these international collaborations possible. We are already doing this. Every country is already doing this. But by collaborating and by talking to each other more than once a year, we are able to do this much quicker for them. And that's really a benefit to these researchers.
So that's a good, oopsie, hello. That's a piece of it is leveraging what we're already doing, but I think there are some other things we all need to do. And I would encourage us to think about those as well.
Sure.
Okay, perfect. But thank you for sharing.
Yeah. So that's also, we are not only talking about NIT research during our meetings. Sometimes other innovations like the Science DMC or eDePert or Persona come up, and we learn from those things. We learn each other about the advantages and the disadvantages of those things as well. So it's not only about NIT Research, the program, about the projects that are involved, but it's also about learning from each other what we already have. So I think that it's more.
I agree. One other thing, and Eli and I have talked about this, and Lauren from ESNet, we're thinking of having a BAFET supercomputing in the fall to invite researchers, scientists, and people who support them to come and tell us how can we help more. You know, what are the challenges you have? What are the needs or opportunities? So if there are others of you that are participating in that, I'm Florence Hudson, I'm at Internet too.
Sure, yeah.
So let me know. Thank you.
So I'd add one thing to that. One of the ways that something that we've found to be very helpful is interacting with the funding agencies that fund the users as well as with the users themselves. Because usually, whether it's a DOE or an NSF or some other, I mean, I know the ones in my country, you all know the ones in your countries, right? But they know in a lot of cases who their big data users are, not least of which because they're having to pay a whole bunch of money to support these people's petabytes of data, right? And just coming up with the list of folks who are already involved in dealing with large-scale data, I guarantee you they've got some pain points, right? And so figuring out who those folks are and getting a functional way of interacting with them on a regular basis is something that we've found to be very helpful.
One thing I think that we could do better is, you know, we're all funded by our funding agencies. They have different objectives, but a lot of the science projects are multinational and global, yes. And we engage with them individually instead of as a collective group.
Yeah.
And that's something that maybe, you know, kind of what Florence was talking on about how we might get better at how we go to them as one unified group and rather than having multiple conversations. So, question?
It's not a question, it's a comment. We are doing in Austria, we are running a project. It's called E-Infrastructure Austria. And in this project, this was started with the libraries. And there are every library from every university in Austria involved. And one of the things what we like to do or what we are doing in this project is to bring 4 groups together. This the libraries, the IT services, the funding agencies, and the scientists. And these are what we are thinking, the 4 important groups which need to work together. And another thing is what we also done in a small country like Austria is we have run a national survey. We asked the scientists what is their need, what is their kind of research data, what is how they are working now, and what they want the institutions to change or to improve. We have run this survey in February to March of this year, and we are now now evaluate the results, and the results will be published in I think in fall, October or something like this. And everybody who's interested in this, what we are doing in Austria, is invited. I can provide you with these results.
Yeah, I would very much like to see that. I'd like to comment actually on something that you brought up. So involving the library people is going to be incredibly valuable. I had a meeting with one of the associate deans for libraries, I think, at one of our universities, and they have a whole bunch of science engagement people, right? They don't always understand cyber infrastructure particularly well, but they understand science very well. And so I think that from the perspective of our community, they represent a large untapped resource. And so building bridges with the academic libraries is something that I think can be quite productive for us.
Thanks. So curious, hearing all these talks, I think there's a good amount of resources that each of your organizations are putting into this research support. I'm just curious if you have any comments about how difficult that is to justify within your own organizations. I mean, getting those resources, I know Eli's kind of looking down and saying, oh my God, yeah. No,
it's an excellent question.
That's a huge part of this, right?
Yep.
I mean, as you're saying, Eli, right? We I think can identify some of these areas where it would be great to be able to put those resources. However, getting them within our own organizations is often difficult. So I'm just curious how all of you have approached that.
So I can answer. So this evolved in ESNet over time, and it's gone from a couple of us on Found Cycles to a group of 4. And the reason that it's grown is that we've been effective, right? We show results. And you have to be a little bit strategic about how you do this. I would recommend that folks don't try to tackle the hard problems first. I mean, especially those of us in technical fields, right? We have this thing, okay, I want to go and knock the big thing over, right? And if I can get the hard thing done, is all going to be easier than that, right, from there on. In this game, I've found that it's really important to go in the opposite direction, right? Pick the low-hanging fruit first. Use that as you've demonstrated success now, and you've done then immediately 2 things. One, you've got a bunch of happy people who can speak on your behalf and say, hey, you know, we got helped. That's great, right? And you've learned something about common problems, common solutions, and so on. And so that makes it easier to snowball an organization if you do it that way. But there's no free lunch, right? All of our budgets are under pressure, every one of us. And so you really do have to make sure that you can show effectiveness. And sometimes it's even as simple as, hey, you know, we helped you guys out, that's great. Would you mind collaborating with us on a short paragraph? And oftentimes, a research group is happy to get the publicity too. But that's really important for our program, right? And that allows the people who fund us to go back to their senior leadership and say, look, see, so what am I doing, right? I'm giving my program manager a token to show that they've been effective by funding us, right? That's a huge win. So figuring out how to do your win-wins, right, for your funding constituents as well as for your scientific constituents helps with that.
Yeah, and I'll say, as a CEO that has limited resources available to me, right, I have to make decisions every day as to where I spend the organization's money. And I see engagement, if done well, as a critical part of the organization, because not only if they're effective at engaging this, the research become more effective, our users are more satisfied, but if they're doing it really well and bringing information back into the organization, it's helping us setting our strategic goals and objectives, helps us do our future planning. It helps us identify new areas that we may need to go into, that sort of thing. So I think an effective engagement team is a critical part of an NREN. But as Eli said, they have to be effective. If not, then I would be better off spending my money in other areas.
Yeah, so if I could contribute to this, can you hear me?
Yeah.
So, following on from what Eli and Siva just said, we have to deliver services that users need and use. There's no point delivering services that nobody wants. And in a way, if you look at the history of Jant and our progression in this area, we've gone from having half a person dedicated to this a few years ago to a team of 4 or 5 people now. That shows the importance, it shows the success so far. It shows, and it's also demonstrated by the fact that the EC is also, who is our biggest stakeholder and biggest contributor to funds, is also pushing very hard on this topic to say, look, you need to develop services that the users need. And the only way to get that feedback is, like Steve said, have this feedback loop with the users. Otherwise, you're doing stuff that nobody wants otherwise.
Yeah. Do we have a question over there?
Yes, Alex Reed from ARNet. I think that what the panel has contributed today is really excellent in terms of understanding the problem that we have of reaching researchers and understanding their needs. I'm particularly interested in the graph that Silvio showed. It's that long tail. How do we get to know the needs of ordinary researchers? I mean, often we know what the particle physicists want because we work with them closely. Same with astronomers and so on. But it's and when we talk to the funders, they usually are focused also on the big users. So how do we get to know the needs of the real end users rather than proxies? We have representatives for them, and maybe they're representing their needs correctly, maybe they're not. I'm interested in the survey that Austria's just done. I know Terina or Gian did a survey called Earnest a few years ago of many thousands of researchers across Europe, and that's a very useful baseline, but it's a problem of scalability and continuity. Their needs change all the time. So I wonder if each of the panel can comment on how can we get to know the needs of the ordinary vast bulk of researchers. Thank you.
Yeah, I mean, that's a very good question. I must say that I am not surprised, but still disappointed by how many researchers I meet that don't know about us and the services we can offer, right? I'm glad every time I meet once I know I've helped somebody more and learned a bit more, but it just goes to show how much more there is to help out there and how much we don't know yet about them. I just think increasing our outreach activities is the way to do this. How to make that more efficient, I don't quite know yet, but I do know that we have to increase our outreach activities. One thing that I have found very useful is working in closer collaboration with other infrastructures which have tighter ties with end users, like I'm talking about EGI, PRACE, and the UDAT. These infrastructures, I find that they are closer to users than we are, so working with them gives us a channel to this long tail of users.
And I can add to that as well. In the Netherlands, we have a board of IT directors, and they are basically sometimes they are directly in touch with researchers, sometimes they are not. But they wanted to have a kind of a Dropbox for their employees, for their researchers, and together with them, and because of their request, we developed, for instance, Surf Drive for the researchers in the Netherlands. And that's been picked up really quickly by the researchers. And it's helping them out to securely and safely store or share data with other researchers. And still, these researchers at the long tail don't know about us. They use stuff that we made for them. They use Eduroam. If you talk to students, they know about Eduroam. Do they know that the NMN is involved in that? They don't. Yeah. So sometimes it's not even necessary to really reach the actual long tail. Sometimes it's just necessary to provide good services that don't need explanations to them. I think the middle part, that's where the actual interesting stuff is for now.
Yeah. I think there's a couple things. I think, one, we can't continue to just do the one-on-one engagement, right? That, as you said, that doesn't scale. So we need to think of other tools available to us, such as social media, knowledge bases, make people aware of places they can go to get the information, do a little bit of self-help. But another thing I think that we need to get much better at is making the network just work. Yeah. Right? If it's always such that you have to know a lot about networking in order to do science, then we're not doing our job the way we should. Right? We should be designing a network so that it's plug and play and it just goes. I know that's the holy grail, right? It's really hard to do, but that's what we should be striving for, in my opinion.
So, Jacob, did you have?
Well, I just wanted to add one thing there, is that's already been mentioned apart. The long tail is so long, there's so many people there that we can't reach everybody there. One thing that can help is understanding some representative use cases, and to make sure that our services are general purpose enough that they serve most of the people most of the time without our direct involvement. The best situation is something like what Sylvia mentioned just now, is if we can provide a service that fulfills the needs of scientific workflow, but that have like a user experience which the people already know from consumer electronics, something like a Dropbox equivalent that doesn't have the drawbacks of actual Dropbox in a scientific or maybe even data security context. Also, the very tip of the iceberg, the really high-powered users, particle physics, they're well served. We're of course keep serving that community, but they're already far along the path. Earth sciences, climate sciences, they're quite well along the path now. What's very interesting to me is new science communities that are now developing a big data workflow that maybe they don't have very much historic context in. I mean, genomics is really taking off the life sciences, but even humanities are beginning to use large data sets, and they have no institutional history of using data. Often they don't have very much institutional history of using any kind of IT. So those are the really interesting cases, what I think is the next generation of user communities that we have to engage with, to understand and to help them get their work done.
Yeah.
Got some questions too.
Oh. Okay. Yeah, I wanted to just add one thing to this, which is and pieces of this have come out in several parts of this conversation. The way I like to look at this is there's if you look at a user that has to deal with large-scale data, they're not doing that on their laptop. And they're probably not doing it on a server under their desk either. They may be trying, but they're not going to be very successful at it. And so we can make a lot of progress, I think, on serving that long tail by ensuring that the large-scale cyber infrastructure pieces work well internally and work well talking to each other. So it should be easy to move petascale data between high-performance computing facilities anywhere in the world across any science network infrastructure. And I think that's actually more tractable than we might think it is, because there aren't actually that many of those. I mean, okay, maybe there are 150 or 200 of these data centers globally. That's very different from 200,000 science users, 500,000 science users. But those users are going to be logging into the large-scale infrastructure in order to do data-intensive science at scale, because they're not going to be able to do it in their cluster in a closet. So I think there's actually quite a bit of leverage in working on making sure that the large-scale cyber infrastructures can communicate well and through effective user interfaces, right? And I don't have to do command line FTP file by file. No, right? We need a better user interface than that. But I think that is tractable, and I think we can actually do it.
So, Jack Seuss, University of Maryland. And so I'm at an institutional level, and what I'm curious about is, as I'm thinking about this problem, and it's sort of building on what Eli said, we're thinking about a new definition of employee, a cyber infrastructure expert that is really there to be working closely with the domain scientists, but also trying to be teaching grad students how to be doing these kinds of things. Because at least what I see is much of the work that happens in the lab gets done by the PhD students who are working in those labs in terms of setting things up. They're directed by the faculty. But if we could be starting to train graduate students in this advanced cyber infrastructure, we could begin to be creating a new generation of users. And I'm just curious, how do we cooperate between the institutions and NRENs to be able to come up with the right curriculum to start to be getting those users trained across various disciplines?
Okay, so we've heard this from institutions, the same idea, and actually some of our institutions in the Netherlands are already implementing this idea. They want to be able to interact more with their researchers, the IT departments and the libraries together. And they are also looking for course material. They are thinking about, should they develop it themselves, or can they use material that's probably already out there from courses directly to students. They're looking for that, and they also feel a need to collaborate more with IT departments and science support staff from other institutions to collaborate with them to make this happen, because they all have to do this for their end users, right? They all have to do this in order to improve science in their institutions. So why not collaborate, right? And we as an NREN are facilitating this collaboration. So we are getting them together more often. We are building this community for them, so they can meet each other, they can get to know each other, they can learn from each other. So we're giving them a platform. And I think that's really, really beneficial, and they really need this, because otherwise sometimes they are a few miles apart and they don't know about each other, they don't know that they have the same questions. It's just so much more efficient if they do meet. So that's what we are facilitating in the Netherlands.
So reaching to the long tail is a real problem. In the U.S., many, though not all, of the long tail scientists reside in smaller institutions. And the National Science Foundation, over the past couple of years, has put out a program specifically to reach the networking crowd, networking staff in the smaller institutions. And one of the requirements of participating in that program is that the networking staff go into the institution, contact the researchers, and make the case for the funding.
Nice.
Yeah. There was a question over on this side.
You're making me sad, because demilitarized zones are the best we can offer for collaboration. They're not normally used for collaboration. They're used for standing aside and staring at the other and hopefully not shooting at them. There is a piece missing of the collaboration infrastructure. None of you have referred to the virtual organization or the work that has been done in the identity space or on self-service interfaces and how to interconnect them into a more holistic approach. One action that might be taken if we want to do something concrete about this is the initial training networks with the Marie Curie actions. And I would encourage you to look more into that. Thank you.
Okay, I'd like to follow up with you on that.
Yeah.
Okay.
Just a comment on the long tail and the type of users. One project I'm following recently is a medical project analyzing large medical imaging files distributed over the whole of Italy. Nothing strange, actually 1 gigabyte files, not very large. The problem are the physicians don't want to understand what the network is for, but they need the network to work. These type of projects are actually increasing the amount of persons in the long tail, even if the total amount of data probably is not so large. So I think that this type of discussion is essential, but we have to take into account that in some cases the researchers overlap with the person that use that as a service for themselves, and just need to understand how to make it work. Not technically, they expect to turn a key and make it work. This means that the middle people that helps them and understand both worlds is becoming more and more essential. And this is one thing we have to look at, educate people or have people there. And my personal conclusion is that it's not useful to talk directly with the physicians about networking and other things. You have to talk to a higher level, because they need to understand that the system has to support us.
Yeah, so the thing that we often find, I mean, someone literally said this to a colleague of mine. This ESNet thing, so we talked to some folks about some of the capabilities of the network. They say, great, ESNet sounds great. How do I log in? Right? And the user interface to so we all understand what networks are made from, right? There's optical transport, there's fiber buried in the ground, there's amplifiers, there's routers, there's switches, there's all this, there's protocols that deal with, keeping routes consistent, and topology has to be loop-free, blah, 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 right? We understand all that. But the user interface to that huge distributed thing is a data transfer tool, or a data portal, or Surf Drive, or the Earth System Grid Federation, right? That's the user interface that the scientist uses. And they need to be able to work to and with and from that user interface and nothing else. So I would agree with you. You are absolutely right. And in a lot of cases, when I'm working with scientists, I'm not teaching them about routing. I could if they wanted to know, but that's not where the conversation starts. Where the conversation starts is, I need my half a petabyte blob over here. I need to put it over there so that the code I run over there can analyze this half a petabyte blob, right? And so what's the tooling that they need to use to effectively do that, right? So I would 100% agree.
We'll have to end it on that. Let's thank the panelists, and thank you for your questions. All right, thanks.
Thanks very much. Let's see, just a couple of quick announcements. You wanted to make sure that we said this. So there are demos during the coffee break. Please do use the app or the web page to give feedback on the sessions. You can throw whatever fruit you want at us, but fire up the app and do it. The conference ends this afternoon, but there are meetings in the afternoon. Lunch is only provided for the people who are registered for the afternoon meetings. And then apparently there is a presidential car museum on the first floor that is free to entry. It sounds kind of cool, so let's check it out. Thanks.
Thanks.